we go. All right, have those things out. We are at 1.3 as you see up here. Constructing parallel and perpendicular lines is what we're talking about today. All right, let's get ready to go. Your compass already should be out from that quiz you had a second ago. Again, if you think you did poorly on that quiz or you don't have your compass, get it on Friday. We will fix that grade. But it's very important that you have one. The program has it on sale. So we're talking about new ones today. Parallel and perpendicular lines. You'll find they're not too bad. So the first one, this is parallel lines. Parallel. Oh, what's that? We're at the top. Perpendicular lines, excuse me.
Oh, that's right. Parallel.
I'm right.
You were right.
Parallel lines. These are lines, that's the name. I think we got the delay going on here. Oh, that's weird. What's wrong with that? That's weird. All right. There we go, now we're working. All right, the parallel lines lie in the same plane and do not intersect. You guys, a lot of you when you're younger, think of those railroad tracks, those roads that never ever cross. That's what parallel is. It is lines they'll never cross, but they're in the same plane. There are a couple different ways to do this. If you go back and try to watch the videos later that we put online, they may be a little bit different, but it's fine. There are multiple ways to get the same kind of construction. I will show you one there that's super easy and also makes a lot of other shapes. So it might be very beneficial to learn that one. So this one says, construct a line that is parallel to a given line and passes through a given point. I know what somebody in here is going to try to do, and it's going to be wrong. Someone's going to take their straight edge. Looks like this. They're going to line it up with that line, and they're going to slowly drag it up to that dot and say, yep, that's my line right there. That's what someone's going to try to do. That is not correct. You would not be right in doing that. Okay? That is a line, yes. We don't know if it's parallel or not because we need to have those marks. So please make sure you're doing this correctly. All right, first thing, this is called the rhombus method. You're doing so. Why? Well, because a rhombus is a parallelogram. A parallelogram, their opposite sides are parallel. So if I can make a rhombus, I can make sides that are lines that are parallel to one another. First thing first, what do I need to do? I need to make a dot somewhere on this line. I put it right here. If you'd like to use the very end of it, go right ahead. That works for me. That's going to be the first step, is putting a dot somewhere on that line. You're going to do it like me, go over here to the left. All right. So, watch what we do here. I'm going to take my compass. I'm going to put the needle on that dot I just drew. So move your compass, put it on the dot you just drew. I'm going to open the compass to the distance of where that dot is. So what I need to do, I'm going to move that right. I'm measuring the distance of that dot. Right there. How do I mark that I made that measure? Well, I'm going to do a little arc. That little arc says, yes, I made my measurement. There it is. Do not adjust your compass. In this method, you only do one adjustment, that distance from the dot you made to there. And then don't change it. I'm going to move my compass down to that line. And I'm going to make a mark. Really what I'm doing is I'm copying a segment. Remember when we copied a segment? I'm copying a segment 4 times. I'm not connecting them, but I could connect this segment right here and this segment over here. And they would be exactly the same length. And once you find more about rhombuses, you'll know that all the sides are the same. Okay, so my compass does not change. But what I'm now going to do is this. I'm going to go to that first mark I made. So move my needle to that first dot up there. And I'm going to make an arc. The arc's going to be over here. So mark it right there. It's a good looking arc. So think about it. If I move my compass up to that first mark I made, where do you think I'm going to move it again? Move it on at that mark. Did I make a mark somewhere else? Yeah, down here. I'm going to move it down there. So put the needle down there. When I do so, connect those. Notice there's an intersection point. I can now take my straight edge, connect that dot to that intersection point. And I made a line that is parallel. How do we indicate something's parallel? You don't need to know it right now, but I'll show you. We use these little arrows. If they have the same number of arrows and they're facing the same direction, they are going to be parallel to one another. Just a way of showing it. Don't write this down, but some of you are wondering, well, why is this called the rhombus method? Well, I'll show you real quick. Do not have to write this down, just watch with your eyeballs. Let's go with a nice deep purple. Watch that first dot I made. There. What did it get small all of a sudden? It shrank.
Does it move?
I don't think so. Yeah, move it a little bit to the top. Good enough. Okay, real quick, see what's going on here. Textual malfunctions. Go deep purple here. Connect this to there. That to there. That to there. And this to there. You just made a rhombus. And we know that all the sides are going to be the same. Don't have to do that, but just showing you what they would look like. Alright. Nice? Nice. Moving on. This one. Constructing a perpendicular bisector. Sounds really tough. We'll figure out. Blank blank are lines that intersect at right angles. Well, you guessed it, or you know we've had thus far, is this word, construction of this word here. So this is going to be perpendicular bisector. Perpendicular bisector. They are lines that intersect at right angles. You can use the symbol blank to indicate two lines are perpendicular. We told you geometry. We try to make lots of shortcuts. We try to do shorthand with a lot of our symbols. Here's a symbol that you will see quite regularly. The symbol for something that is perpendicular is an upside down capital T. So make a capital T and turn it upside down. Anytime you see that symbol, that means perpendicular. So an example, you could say something like segment AB is perpendicular to segment CD. That would be an example of it. That's how you would see it. Next, the blank of a line segment is perpendicular to the segment at the segment's midpoint. All right, here we go. Try our first symbol out. The perpendicular bisector of a line segment is a line perpendicular to the segment at that midpoint. What that means is this. It's going to cut a segment in half, and that line is going to be right at the midpoint. That's all it is saying. So let's try this one out. We haven't done this one yet. We haven't done a perpendicular bisector yet. So let's see if we can figure this out. All right. Compass, engage, nice green. What you do here is this. Take your compass, put it on one of the endpoints. Open the compass past halfway. Doesn't sound pretty familiar here. I'm going to do a semicircle. And then I'm going to do another semicircle. Do not adjust your compass. Go to the other endpoint and make that new semicircle. I wanted to do a different semicircle. Okay, we're done. And down, up. You see where they intersect above and below the line? You take your straight edge and you connect it. What I was trying to do, I messed up, I failed at it because I'm so good at this. What I was trying to do is draw my line a little bit short, because sometimes when you guys do this, like you see yours off the page a little bit, you're not going to be able to catch that bottom one. If that happens, you're going to have to just go back and make your line a little bit longer. You just make yours a little bit smaller, but we'll give you room on the other one. But now that I have these lines that are connected like this, I'll take my straight edge and I connect them like so. And there it is. Now, if you notice, this is exactly what we did for segment bisector. We told you this is the most important one you're going to learn. Perpendicular bisector you use for a lot of these constructions. So if you're going to learn one construction, this is it. Because it makes a perpendicular bisector. So it creates 90-degree angles, and that's what we want. A lot of shapes have 90-degree angles in them. But it also cuts a segment in half. So I can say that that measure of that piece, measure of that piece, they are equal. Those are congruent pieces. All right? That is it. Questions on that? We've already done this before. You'll use this one a lot. Perhaps even more today. I don't know.
We look at the next one. We're constructing perpendicular lines. In this case, it has to be perpendicular to this line and pass through that point. So pretty much, this is really similar to what we did last time. Yes, here. Can you wait like 2 seconds? Then you can go. We're done. Really similar to what we just did. The issue is we're not putting it directly in the middle of this line, right? It has to go through this point. So what we're going to do is kind of section this line off and then just do the perpendicular bisector of that section. You're going to take your compass, put the needle on the point, and then you are going to drop it right down so it's past the line. Not like hugely past, just a little bit past. Doesn't have to be really far. And then what you're going to do, once you do that, you're just going to make an arc so that it touches the line twice, like so. Put your needle on the point, drop your compass straight down so it's a little bit past the line, and just make an arc so it touches the line twice. Okay? So we're going to ignore the rest of the line. We just now kind of created this small segment. And we're just going to perpendicular bisect that segment. So it's the same, at this point, it's the same exact steps as the last one. Okay? You're going to put your needle on one of those intersection points. Go more than halfway, and it's nice because this point is halfway. So make sure your pencil's past that point. Make your semicircle. Okay. And then just like the last example, put your needle on the other point. Make your semicircle. And then line up your straight edge with those intersection marks, and it should go, the line should go right through that point and the intersection point. Whoops. There. So just like the last one, just like perpendicular bisector, you just have one more step beforehand. You just have to put your needle on the point, open up the compass so it goes past the line, draw an arc so it intersects the line twice, and then you have these two intersection points. And then you just do a perpendicular bisector of this little segment you make. You're ignoring the rest of the line. It doesn't matter anymore. Questions over that? Okay? Number two, really similar to the last one. Okay, you have to section off this line and then do a perpendicular bisector of that section. So take your compass. Again, Beginning steps as last time, you're going to put your needle on the point. I'm going to open up my compass towards the smaller end. So I'm going to open up the pencil so as far as you want. I'm going to go about right there.
Stay on the line.
Stay on the line. Okay? If you went the other way, you might have opened it up that far, but at that end it's not on the line. It has to be able to touch the line on both sides. So we're going to go a little small. That's good. Okay? Same exact steps as last time. You're going to make an arc so it intersects the line at two parts. That looks like a Pokemon ball. You Pokemon Go people. Okay? Gotta catch 'em up. Okay? Then, exactly like last time, you made these two intersection points. And you do a perpendicular bisector of this little segment you made right here. So you put your needle on one intersection point and get it nice because the point's the middle. So just make sure you open it so it goes past the point. If you're right on the point, the lines aren't going to intersect. So make sure you go past that point.
You have to adjust. Students earlier were keeping the same measurement, like they don't intersect. No, because they'll never touch. You gotta open it past.
You make one arc on one point, go to the other intersection point, make your other semicircle, and then line up your straight edge. And it should go both through both intersection points and that point like that. So again, it's just like doing the perpendicular bisector construction. There's just one extra step. Right? You have to put your needle on the center. Open it up. Make an arc so it touches the circle twice, and then do an perpendicular bisector between those 2 points. Okay. Questions over any of that? Okay.